The Deccan Plateau is a rugged, sun-baked expanse running through the interior of southern India. In the 12th century, the Kakatiya Dynasty began aggressively reshaping this terrain. Over 200 years, they engineered a network of 5,000 interlocking lakes and irrigation channels, turning dry, unforgiving earth into a thriving agricultural stronghold. Their engineering ambitions peaked at Warangal Fort. The Kala Thoranams, massive stone gateways cut with precise geometric symmetry, stood as the imposing borders of their power. The Kakatiyas were attempting to construct an empire carved entirely out of solid rock, pushing medieval construction methods to their absolute limits to build something permanent. Permanence is rare in this region. Structures built on the plateau face intense tectonic pressure from deep underground, and historically, they faced relentless human conflict on the surface. In the 14th century, the Delhi Sultanate launched a series of brutal military campaigns. Generals like Malik Kafur sought to systematically dismantle the Kakatiya strongholds, erasing their monuments piece by piece. The physical evidence of this violence remains scattered across the state. Walk through the Thousand-Pillar Temple or the remnants of Warangal Fort, and you find shattered pillars and decapitated statues, the quiet aftermath of targeted invasions and deep earth tremors. Yet, 77 kilometers away, in the remote village of Pochampalli, one structure survived both the invasions and the earthquakes completely intact. The 13th century explorer Marco Polo documented this anomaly, calling it the brightest star in the galaxy of temples. The temple's preservation forces us to examine the specific structural logic an architect used to protect a massive stone complex from the Deccan's most violent seismic and historical threats. Commissioned in 1213 AD by a general serving King Ganapati Deva, this is the Ramappa Temple. It holds a rare distinction in Indian history. It is not named after the king who funded it, nor the deity housed inside. It is named solely after its chief sculptor, Ramappa. Historical records suggest his process was highly unorthodox. Long before breaking ground, Ramappa spent years building meticulously scaled models of the entire complex, physically testing the loads and stress points of his design. The construction consumed 40 years of his life. This intense focus produced a fail-safe engineering master plan disguised as a place of worship. To understand his methods, you have to ask how you earthquake-proof thousands of tons of stone in the 13th century. This cross-section shows the first layer of defense. Rather than building directly on bedrock, Ramappa began by excavating a massive pit deep into the earth beneath the temple's footprint. He filled this void with a highly specific mixture: fine sand, lime, and jaggery. This composition acts as a giant subterranean cushion. When the ground violently shifts, the loose grains of sand move and slide against one another, absorbing and dissipating the kinetic energy instead of transferring the shock waves into the rigid stone pillars above. By neutralizing the Earth's violent forces deep underground, the temple's survival was secured before a single block of masonry was ever placed. Above ground, the temple rests on an elevated, star-shaped platform. Here, Ramappa constructed the load-bearing pillars out of black basalt, a volcanic rock known among stonemasons as one of the hardest and most unforgiving materials on Earth to carve. Despite the extreme density of the rock, the pillars feature Madanikas, dancing figures, carved with such delicate, wax-like filigree that the stone appears practically weightless. This precision extends to the massive Nandi statue facing the shrine. It is heavily polished and engineered with an optical trick, carved so its eyes seem to follow the viewer from any angle. Ramappa intentionally selected the most difficult materials available, combining structural rigidity with an extreme mastery of carving to ensure these details would never erode. A heavy stone roof, known as a vimana, is the most vulnerable point of any ancient temple. During a tremor, a top-heavy mass will sway and pull the supporting pillars down with it. This schematic illustrates how Ramappa solved the weight problem. He drastically reduced the density of the roof structure, developing a 13th century equivalent to modern autoclaved cellular concrete. To achieve this, the builders mixed traditional clay with acacia wood chaff and extracts from the myrobalan tree. When fired, the organic matter burned away, leaving a network of microscopic air pockets. The resulting brick is so extremely porous and lightweight that it literally floats on water. Capping the temple with a nearly weightless roof severely reduced the structural load on the basalt pillars, finalizing a perfectly harmonized, earthquake-proof design. That engineering faced its ultimate test 400 years later, when a massive, violent tectonic shift rocked the Deccan Plateau in the 17th century. This cross-section shows the physical toll. Underground pressure pushed the heavy granite floorboards upward, warping the temple's base. Yet, the core mechanisms triggered as intended. The sandbox foundation absorbed the shockwaves, and the lightweight roof prevented swaying. The vertical pillars remained completely intact. Ramappa's 40-year construction project successfully defeated nature's ultimate test, proving his structural logic was flawless. On July 25, 2021, the modern world finally acknowledged this 800-year-old marvel. The Ramappa Temple was inscribed as India's 39th UNESCO World Heritage Site, and the very first for the state of Telangana. The Kakatiya legacy is a physical record of a civilization that successfully fused high-level material science with its most ambitious creative instincts. The Ramappa Temple stands as a functional proof that when visionary art is anchored by resilient engineering, it creates a structure capable of enduring through centuries of seismic and historical upheaval.